Good evening. How are you, Vishnu?
I'm fine.
Okay, let me open the. Okay, so we'll start now.
Yes, sir.
In the last class, we are covering topics of phenol, huh?
Phenol. Yes, sir.
And I think the reaction we are covering is electrophilic substitution on phenol. Can you tell me last reaction? What was the last reaction in your notebook?
Phenol plus uh, benzene with SO2CL, sir. Pyridine.
Okay, okay,
Right.
okay. Yes, I understood. So those are the reaction in which phenol is having a property of nucleophile. It is acting like nucleophile, huh?
Yes, sir. Yes, sir.
So does
Yes, sir. Actually,
yes, Vishnu.
the last Sunday they conducted exam on alcohol, sir, because last week the exam they skipped the exam due to some issues.
Okay,
So last Sunday they conducted the exam on alcohols.
okay.
So this week we are having ethers, phenols, ketones, and aldehydes.
Okay. So this week you have attempted test for a phenol, huh? Or phenol will be topic for coming test.
Coming test, sir.
Coming test.
Ethers, phenols, ketones, and aldehydes. So,
Okay. So the coming Saturday and Sunday, definitely. In fact, we have
yes,
completed almost most of the part of phenol, and we need to start aldehyde. Huh?
yes, sir. And ketones and aldehydes also not complete, sir. They are like
It
basic preparation.
only basic preparation. Yes, I can recall the syllabus. Yes.
Yes, sir.
Just. So my voice is clear, na?
Yes, sir. Yes, sir.
Okay.
Sir, I sent you this.
Yes. Yes, I have recalled. Huh? I remember. Huh? We have some reactions of Grignard. Huh? No. It is. different, huh? Ether, then we have phenol, Reamer diamond, okay, Colby reaction, yes, spin synthesis, okay, these are the reaction of yeah. Yes. I think something is revised in the syllabus. Huh? Okay. Let's start
No,
with.
sir, it's the same actually.
Okay, okay. Then I was missing some topics. Yes, but very good. You have sent this. Okay. So in the last reaction, we have attempted reactions of phenol with the benzene sulfonic acid. Yes, with the presence of pyridine.
Right.
Look, there is one more reaction, huh?
Yes.
Actually, some connection was. Let me check this. Okay, now it is. So, there is a reaction of phenol with ammonia. Look, this in this reaction, what we can, like as a student, like if someone is having general knowledge of organic, basic knowledge of organic, then how he will approach? Look, and 300 degrees Celsius. Like as a student, it is very clear to me that this ZnCl2 will act as a what? Lewis
Yes, sir.
acid, and the reaction is carried out at 300 degrees Celsius, huh? So
Yes.
this is the condition of what? Higher temperature.
Right.
Huh?
Yes.
So these two things will facilitate removal of OH from the benzene, and this ammonia, which will act as what? Nucleophile, and get attached to form final product, and the final product will be NH2. This, like we are not going into detailed mechanism here, but the basic understanding of reaction is required in most of the cases, and
Yes.
for uh, for a number of reactions, we need to understand the mechanism also. Okay, so these are some reactions in which you need to understand the basic point, how this reaction can be identified as a student. Like uh, you don't need to remember the reaction, you need to identify the condition, and that condition will facilitate removal of what? OH.
Oh,
And when OH will get removed, there will be nucleophilic attack from what? Ammonia. And when ammonia will make nucleophilic attack, it will become positive. Nitrogen
yes.
of ammonia will become positive, so H plus will be removed.
Yes.
That H plus will combine with the OH minus, and along with that, what
Yes.
we will get? H2O. And where this H2O will go? This H2O will go with the ZnCl2. Huh? Okay.
Yes, sir.
So that ZnCl2 ultimately facilitate the removal of OH. So this is the basic point we need to understand. Okay. Then another reaction. We are reacting it with PCl5. So again, the product will be what? OH. The OH will be OH of the substrate will be replaced by what? Cl. So
Yes.
again, for this reaction, mechanism is not required, but we can relate the reaction with the product. Huh? So
Yes.
how will relate? So the point is that this PCl5, we have seen alcohols, we have seen in alcohol that alcohol reacts with PCl5 and gives what? RCl, and along with that POCl3
POCl3. Yes.
and HCl. So this reaction is under the similar condition. Phenol will also under some extreme condition. In fact, for this reaction we
Yes.
need to get some extreme condition, means higher temperature and pressure. So that micro detailing is not required, but there must be understanding in the student that this removal of OH will not be easy, that
Yes.
it will not be easy to remove OH from the benzene. And why? Because there will be double bond character between the oxygen and carbon.
Yes.
Huh?
Yes.
So that
Yes.
double bond character will oppose removal of OH, but under extreme
Yes.
condition reaction may take place, and here we have seen. Huh? So mechanism is not required, that's why I am just mentioning the reactant and the product. Similarly,
Yes.
if we react phenol with the zinc, what will get? We'll get benzene plus ZNO. Keep this reaction in mind. Like in when I study chemistry, I feel chemistry in a different way than maths and physics. In chemistry, I say some reaction like chore reaction. In Hindi, chore reaction, thief reaction. Okay, we know that is very general reaction, but sometime appear in a advance. Like the statement will relate you that your like in the advance you will find that the statement relates you a particular word or particular reaction relates the all information, and sometime
Yes.
you will find this reaction will appear. So how we reduce how we reduce phenol into benzene? By using zinc. Okay.
Yes.
Okay. So these are the reactions. In all these reactions, what we are doing? We are removing OH. Huh?
Yes.
We are removing OH. Okay. So these are the reactions. Huh? Next variety we are going to understand electrophilic substitution reactions of phenol. Electrophilic substitution reactions of phenol. Okay. So the first reaction, when phenol is reacted with Br2 and the medium is taken carbon disulfide, temperature 0 degrees Celsius, it forms bromo substituted product. That will be bromine will be at the para and at the, and what will be the other possible position for bromine? Ortho. Meta will not be possible. Huh?
Yes.
Okay. And the reason is very clear, na? Because these lone pairs will have plus R and that will create delta negative on the ortho.
Yes,
and
sir, yes.
okay. Okay. So this is the condition. Again, the same substrate, this phenol is taken with what? Br2, and the reaction is carried out in aqueous medium, water. What was found? This time phenol get tribromo substituted. It will get tribromo substituted. Okay. So we can see there are same substrate. What is the difference? Difference of solvent, and this difference of solvent brings what? This difference of solvent brings difference in the product. It is mono substituted. and it is tri-substituted.
Yes.
Okay. So mono substituted, tri substituted. So
Yes.
do you like to relate this phenomena, this observation with some concept? Any word? Think about this. Why? What is the difference? Difference is the solvent. So try to relate the property of solvent. What will be the structure of CH2? If we want to understand the property of this CH2 solvent, we must know the structure of CH2. Carbon disulfide, it is called carbon disulfide. Similar to carbon dioxide, when it is CO2, it is carbon dioxide. In place of oxygen,
Yes.
it is a sulfide. So what will be the structure?
C double bond as well.
Okay, and the structure for water is this. So what is the difference in these two molecules? This will be non-polar,
Yes.
and this one will be what? Polar. So what do you think? Non-polar and polar, the difference in the nature of solvent. Why this difference in nature of solvent changes the nature of product? Why the difference in nature of solvent? By the way, among these two mono substituted, this para will be major
Yes.
and this ortho will be minor.
Minor. Yes.
So, what do you think? Anyone, if you are having good understanding of chemistry, you can try. Okay, don't worry. I am putting some
Yeah.
base. I am breaking these questions in some more step. Let me try. What do you think? Reaction will take place by what? This pi bond will be donated to the bromine, and this bromine will, and there will be intermediate like. I'm just. Do you like to draw the intermediate? Just try to draw the intermediate. Show me into the camera. There will be bromine attached to the carbon, Yes.
Yes, sir.
Yes. I think you are showing your notebook, na? You can show me. Yes. Very good, very good, very good, very good. I have seen the first one. Okay. So this will be the intermediate. So what we find? The reaction will have ionic intermediates, Charge species are the reaction intermediate, and the solvent is what? Non-polar, and in the second
Non-polar.
case solvent is what? Polar. So
Polar.
what is the we have seen this sentence in the even in the up to 10th, that like dissolve like, have you heard about this
Yes.
proverb,
Yes.
like dissolve like? So if the species are ionic, it will be better stabilized in what? Polar solvent.
Yes.
If the intermediate is ionic species, charged species, it will be better stabilized in the polar solvent. And if the
Yes.
solvent will be polar, then it will be stabilized better, and that result into what? More tendency of this kind of reaction. So like this hydrogen, like the hydrogen at ortho, para, the hydrogen at both ortho position can also be substituted by what? Similar substitution by reacting with bromine. Like so, what you need to understand from this phenomena? Just I try to explain this. What you need to understand by this phenomena, that if solvent is supporting the reaction, the reactivity will increase, and if the reactivity will increase, this hydrogen, all three hydrogen will get substituted. What are the other
Yes.
advantage? The other advantage is the benzene is having plus R effect from the OH. So that is also
Yes.
supporting the what? And electron donating nature of this ring. Huh? So
Yes.
polar solvent with the plus R effect of OH combinedly makes this ring so much electron rich, and its reactivity become very high, and all three hydrogen get substituted by the what? Bromine. Huh? Understood?
Yes, sir.
Okay.
Yes.
But in case of non-polar solvent, definitely reactivity will decrease and only
Yes.
mono-substituted product will form, in which para will be major or and this will be ortho will be minor. Understood? No? So we can
Yes, sir.
write this sentence in fact due to these sentences are important for the advance. Huh? They may
Yes.
compare reaction like this. Due to polar nature of solvent, there will be increased reactivity of phenol for electrophilic aromatic substitution reaction. Okay, so this is the point we need to keep in mind. Huh? Okay,
Yes. Yes.
okay. So the next point, suppose we want to prepare phenol, we want to convert phenol into this ortho. This is our desired reaction. Huh? This is the
Yes.
desired product. Then both of the above method that we have seen, previous methods, will not be suitable. The second one will be totally rejected because it is tribromo substituted, and the first
Yes.
one is also not a very favorable reaction
Effective.
because the
Yes.
our desired product is minor product. Huh? So
Yes.
there
Yes.
must be some uh, steps involved. So for such case, what we do, not only this, you will find this reaction, this step applicable in many cases. So I am just first making the introduction of concept in this reaction, then we will generalize it for many reactions. Huh?
Yes.
Okay. So
Yes.
this phenol will be first sulfonated. Huh? Sulfonation. Sulfonation. So do you remember the reagent for sulfonation? Huh? SO3 plus H2SO4. Huh? We call this mixture as oleum.
Yes.
Now you will go oleum. Huh?
Oh.
If you I I find your today I find your internet
Yes.
speed a little bit slow. So if you find anything difficult, you can ask. Huh? I will repeat that.
Volume. Yes.
So this is called oleum. So this is the reagent used for sulfonation.
Yes. Yes.
When sulfonation is done, under the controlled condition, it will be disulfonated. Huh? This will be the product. This product
Hello,
will
sir.
form. Yes, yes,
Hello, sir.
yes, yes, Vishnu. You are audible to me. You are audible to me.
Sir.
Yes, 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 Vishnu.
Hello, sir.
Yes, am I audible to you?
Yes, sir. Yes, sir.
Yes. For a moment, you
What?
actually you know, when I teach in online, na, I observe student face, and that helps me in, like, when your voice is breaking, na, before that your picture will start freezing. So whenever there is an internet problem from student side, we come to know that now student is facing some problem. Okay, so definitely in such situation, don't worry, I will repeat the thing. So sometime it happens, some drop will be there, some drop, sometime it may appear. Okay, so this is the method under the controlled condition for sulfonation of phenol. What we get? We get disulfonated phenol. Disulfonated phenol. We form this, and when this will be done, the next step will be, will react this with what? Br2. When it will be reacted with Br2, NaOH, Br2 NaOH, it form NaOH will make it O minus. This SO3 will become SO3ONA. SO3Na. And this will remain SO. This will also change to SO3Na, and bromine will get this ortho position. Okay, and remaining the pi bonds are there. So this will form. So what we have done? We first block two positions, one ortho and one para. Like when sulfonation will be done, the first preference for sulfonation will be para.
Yes.
And when we will provide higher amount of sulfonation, the next position occupied will be what? Ortho.
Ortho.
If we provide even more higher amount of this reagent for sulfonation, then the remaining ortho position will also get occupied. But as a when we conduct any reaction, we carry out any reaction, we know at that point that yes, we need that much amount of sulfonating reagent to get only what? One ortho and one para position occupied. Now, under this situation, if we provide any electrophilic attack on this ring, the position which can be used by the electrophile for the attack will be what? The remaining ortho position. Yes or no?
Yes.
And this electron will be donated. And we are taking this basic condition. So basic condition will put this H plus out, and here minus will appear. Similarly, this H plus will be out and minus will appear. Similarly, this H plus will be out and minus will appear. Okay.
Yes.
Finally, reaction will take place and this product will form. It is clear to you? Okay.
Yes.
So now, the sulfonation, in the sulfonation, the reaction, the nature of reaction for sulfonation is reversible. Whenever we do, sulfonation is what? Reversible in nature. Sulfonation is reversible in nature. So what will happen? Now, under the acidic condition, if we provide acidic condition to this product, that is SO3Na and Br, if we provide acidic condition and heating, this sulfonic group will get attached and the remaining bromo will remain at the benzene. Because bromination is not reversible. What is reversible? Only sulfonation is reversible. So sulfonic group will get away from the benzene ring, and those positions will be now free. So we get finally desired product.
Yes, sir.
Hey, what are you doing? Don't do that. Yes. I will explain this line with a lot of points at the end of organic,
Yes.
but during the next 10-15 classes, we will use a number of time. While solving question, you will find this point very useful. Huh? You will find this sulfonaceous
Yes, sir.
is reversible. Okay. Okay. So this is the way we can prepare bromo substituted phenol. Okay. Now
Yes, sir.
if we do nitration, huh? We take phenol and nitration. What is the reagent for nitration?
HNO3 plus concentrated H2O.
Very good. HNO3 plus concentrated H2SO4. Yes, very good. Okay. So when the nitration will be done, this phenol is already what? In the phenol, benzene ring is highly activated due to presence of what?
Yes, sir.
OH. And the condition is what? Aqueous condition. Huh? Concentrated means what? There is a aqueous condition. Huh? Solvent is there.
Yes,
Na?
sir. Yes, sir.
So what will happen? Nitration will take place at higher magnitude, huh? And in
Yes.
place of mono substitution, will find tri substituted product.
Yes, sir.
Okay, and this compound is called picric acid.
Yes.
Picric acid, very famous compound. Huh? Picric acid does not have like common. Phenol is not a very common acidic group. Huh? It is a very mild acid among organic acid. Or, organic acids are itself are very weak acid, and among organic acid it is a weaker one. So generally such
Yes.
compounds does not have acid as a their suffix. Huh? But in case of picric acid, due to presence of these three NO2, the acidity become very strong, and this compound is having this suffix acid. Huh? So what is the role of this NO2? Do you like to give one liner for role of NO2 for increasing its acidic strength?
Sir, it's an electron withdrawing.
Yes, it is electron withdrawing. So when negative charge will appear, very good, electron withdrawing. Okay. That will get delocalized and reaction product will be stabilized. One more point,
Yes.
when we perform nitration, most of the phenol get oxidized and get converted into terry product. Huh? Like if you are doing cooking, during cooking what we do? We convert macromolecule into what? Micromolecule. During cooking process, when we cook food, what we do? We convert large molecule into a smaller one.
Yes.
Suppose there is a food which is very easy to get burned. Huh? Some foods, when
Yes.
some recipes are prepared, mother they repeatedly move the items. Huh? So in such
Yes,
cases,
yes.
so why that is required? Because a smaller amount of localized heating may convert our compound into some terry thing, terry, the black substance. So actually during
Yes.
nitration also, during this condition, most of the phenol we will take will get converted into what? Terry substance, that is the oxidized product, that is the residue, you can say, that is, you can say, the amount get when you can say that is not a desired product. So only a small portion of phenol will get converted into picric acid. That is the point
Yes.
I want to make here. So most of the phenol will be converted into terry. A small amount fraction of that phenol taken will get converted into. So what we can say, yield of reaction will be small. Huh? In the simple word,
Yes.
what we can say, yield of reaction will be small. Huh? Sometimes
Yes.
that simple sentence is not coming to the mind. Huh? But that is required.
Yes.
Yield of reaction will be very small. You can write this point. Yield of reaction will be very small. Okay.
Yes.
So suppose we want to form ortho substituted phenol. Huh? want to form ortho substitute. This is our desired product. Huh? From phenol, we want to form ortho substituted phenol. What we will do?
Sulfonation.
Very good. So
Sulfonation.
first we will go for sulfonation. Huh?
Yes.
Mm, no, let me correct myself. Again, we'll make picric acid again. But what we are going to do? We are going to reduce the terry substance. Huh? We are going to reduce the terry substance. So for what we will do? We will first do sulfonation. But again, sulfonation will be required. What will happen? The ortho and para position will be occupied.
Yes, sir.
Then at this condition we add HNO3 in the cold condition. HNO3 cold. Then what will happen? Again the sulfonic group, due to HNO3 is acid, so that acid will facilitate removal of sulfonic group. Getting my point? The acid will facilitate removal of sulfonic group. So sulfonic group will be removed, then NO2 will come here. But what is the benefit of sulfonation here? The amount, yield of reaction will be high. Yield of reaction will be high. So for this reaction, yield will be high.
Yes.
Yield of reaction will be high. Okay.
Yes, sir.
Suppose let me, but this example is important. Suppose we want to make this one. We want to make this one,
Yes, sir.
or only one. This is our desired product. Then we can't start reaction with the phenol. Why? Because if we start reaction with the phenol under any condition, it is going to be tri-substituted product. So cook. Okay. So what we'll do? We start with the chlorobenzene. In the chlorobenzene, we'll take nitration, HNO3, H2SO4. What will happen? Under controlled condition, we'll get mononitration. Under the desired change in desired condition, we can get what? Dinitro and trinitro also. Okay. So, but here our target is mononitration. So we have done mononitration. Then what we'll do? We'll do NaOH heat. This NaOH heat, Na plus OH minus. We have seen.
Yes, sir.
Aryl halides under extreme condition may also get into what? Nucleophilic.
Yes, sir. Yes, sir.
Nucleophilic
Substitution.
substitution. So why this sequence is important? Because under this sequence only we can get what? Mononitro substituted phenol. That's why this sequence is important. Okay. Then we can have phenol with NaNO2 HCl 0°C. This is the reaction. Benzene diazonium will form if this OH, in place of OH we have NH2. Huh? Then only we can have
Okay,
benzene.
okay.
Yes, yes. Huh?
Yes, sir. Yes,
Okay.
yes, sir. Yes.
So don't worry, you can answer. So what is the reaction? If this react, it forms what? NO plus. First there is HNO2 and NaCl formation. Huh? Then further this HNO2 reacts with HCl. This H protonates one of the OH of HNO2 and get away
Yes,
the
sir.
H2O from the nitrogen.
Yes, sir.
Do you able to relate? No, this is the structure.
Yes, sir. Yes, sir.
No, I have seen many times some students simply say yes, yes, and these are not a difficult thing.
Ah, no, sir. I remember that.
Okay, so NO, what we get out of HNO2, H2O, there will be addition of H plus, then removal of H2O. So
Yes, sir.
NO plus will be formed along with that H2O and Cl minus. This NO plus will act as what? Electrophile. Look, when this NO plus is reacted with aniline or any RNH2, just for the sake of understanding, I am repeating this point and you can also contribute if you want. So if NO plus is reacted with this aniline or primary amine, what happened? There is a formation of diazonium. There is a formation of
Yes.
diazonium. And in this diazonium, this N2 plus leaves is a very good leaving group. Very good leaving group. And this N2 when leaves, it become gas. And gaseous, when it changes to gaseous phase, it come out of reaction mixture. And that result into what? Removal of
Removal
product.
of product.
That's
Yes,
why
sir.
reaction goes to
Which
this
will
side.
present more product.
Yes, yes, very good.
Yes.
That's why reaction goes to this side. Very good. But in
Yes.
case of OH, no such phenomena can occur. Oxygen will not
Yes.
form like this. So what is the
Yes.
option left with the NO plus? Now NO plus can act as what? Electrophile. And any
Yes.
electrophile when appear phenol provide either ortho position or what? Para position.
Para position. Yes,
So
sir.
what will happen? There will be two product at para and product at
Product at
ortho.
ortho.
What do you think? Which one will be major? Which one will be minor?
Sorry, para will be major.
Para will be major. Very good. Para will be major. Very good. Okay, and this will be what? Minor. Now, if this product is further reacted with what? HNO3, it acts as oxidizing agent. This HNO3 is oxidizing in nature, acts as oxidizing agent and changes this NO into what? Changes
NO.
this NO into NO2.
NO.
So this is again another method for making mononitro substituted product.
Yes, sir.
And the HNO3 used here is dilute. Keep in mind, dilute HNO3.
Yes.
Okay.
1 minute.
Oh, yes. Yes.
Yes, sir.
Okay. So the next reaction we are going to understand the reaction of phenol with alkyl halide in the presence of AlCl3. What do you think? What will happen?
Chlorine will
Yes, the reaction will. This is Friedel-Crafts alkylation. This is the reagent for what? Friedel-Crafts alkylation, and this time
Yes,
what
sir.
we have taken? Phenol as a
Phenol.
benzene, benzene or benzene derivative. Huh? Phenol is the benzene
Yes, sir.
derivative. So what will happen? This this will generate R plus electrophile.
And yes, sir.
So
AHA for
do you like to write the product?
Sir, so known that from oxygen will nuclear attack and sir. It will
So
from ROH and it will be separated and sealed.
okay. So why not the bond pair of this benzene ring? That can also attack, na? Huh? Or
Yes, sir.
you can say the bond pair at from the para position. Huh? So your point is genuine. Huh? I will come to your point. In fact, I like this when some student raise like point. No? We can compare here. Huh? And that comparison is very important in the understanding of organic. Huh? Like I have drawn like this. Huh? And what you have said? You have told that
Lone pair.
lone pair of oxygen will have nucleophilic attack at RCl. Huh? So the question arises, if you take this reagent is what? This reagent is electrophilic reagent, huh? Electrophile.
Yes, sir.
And the nature of our substrate, this substrate is what? Substrate is
Nucleophile. Nucleophile.
nucleophile. Huh? Very
Yes,
good.
sir.
So nucleophile is having two possible sites for donation of electron. Huh? So
Yes, sir.
this is again what the concept appearing here is what of ambident. Huh?
Ambident. Yes, sir.
Ambident. And in case of ambident condition, what I have told you that you need to understand soft nucleophile. Actually, when there will be revision time, na, like when syllabus will be finished, I will give you a concept of soft acid, soft base, hard, soft acid, soft base, hard acid, hard base. Huh? So
Yes, sir.
what is soft acid, hard acid? What is soft base, hard base? When you will understand this, you will relate thing with the soft acid is related with soft nucleophile, and a soft base is related with soft electrophile. Huh? And hard
Yes, sir.
acid is related with hard nucleophile,
Hard nucleophile.
and hard base is related with hard electrophile. And what is the understanding we have up to now? That soft react with soft, hard react with hard. And
Hard.
how we identify soft electrophile, hard electrophile? How we identify soft electrophile, hard electrophile? Can you recall? Hmm? Or you can check your note. No problem. Just check your note.
Actually, it is in other
Okay, okay. Then let me explain. No problem. Actually, soft electrophile means low intensity of positive charge. Huh? And hard electrophile means high intensity of positive charge. Huh?
Yes.
When it comes to soft nucleophile, hard nucleophile, soft nucleophile is
Low intensity of negative.
it is less electronegative atom. Donor atom is less electronegative. Electronegative. Donor atom. And hard nucleophile means more electronegative donor atom. No problem. This is the point you will find 2-3 times again in the next classes, huh? Then things will be automatically in your mind. Huh? Okay. So basically, when this reaction occur, a little bit complicated reaction, I need to present one more parameter of this reaction. Like before explaining, we have gone through all these things. Now, one more thing you will relate,
Yes.
then I will come to the reaction also. There is one more possibility that this lone pair is what? Lewis base. And this AlCl3 is what? Lewis acid.
Lewis acid.
And this AlCl3 is Lewis acid, that's why it has taken electron from Cl and form R plus and AlCl4 minus like that. Huh? But this time we have another donor atom. What? Oxygen. We have another donor atom. What? Oxygen. So if oxygen is the donor atom, in place of chlorine, this Lewis acid will react with what? This phenol.
Oxygen. Yes, sir.
So a student may go to this path that you have told me. Another student may go to this path that I have proposed. But there is one more possibility that for going to this path, this Cl is, if we are taking second path, in the second path, the removal of Cl is facilitated by what? AlCl3. And if there is a possibility that AlCl3 get reacted with substrate, then reagent will not get opportunity to find this step. Huh? And why? Because
Yes.
the catalyst is, AlCl3 is a catalyst, it will be in a smaller amount. And when things are in a smaller amount, some of the substrate molecule will be sufficient to engage all the catalyst added, and that will lead to what? The possibility for this step will be what? We can say this will not be possible because AlCl3. So this is the point basically. When we go this reaction, when we write this reaction, actually what I have tried, we have already seen Friedel-Crafts alkylation. Huh? We have seen Friedel-Crafts alkylation, if you can remember. That time we have taken benzene with the what? This is the reaction of hydrocarbon. In fact, this reaction, have you seen this reaction in the class?
Oh, yes, sir. RCl will react with AlCl and form AlCl4 minus.
Yes, and this R plus will get one. This is like this.
Yes.
So if someone is doing the same reaction, he may find that as per the Friedel-Crafts alkylation, he may lead to what? If this position is occupied, ortho and para will be the position of electrophile, and we have taken para position as major. Huh? And ortho position will be what? Minor. So that may be the case. Huh? But again, this case will be denied. Why denied? Because the OH, lone pair of OH will engage with the catalytic amount of AlCl3, and when the catalyst will not be available for the process, reaction cannot proceed. So what we need to do? We'll add plenty of catalyst. Huh? We'll add plenty of catalyst. So what will happen? Under this condition, this phenol will react with AlCl3 and it will give OAlCl2. Huh? It will give OAlCl2.
Yes.
So this is the organic. Huh? Like you have in your thought process, you have think about this substrate correctly, that oxygen will donate lone pair, but you have taken the lone pair to the alkyl. In another approach, what we have said, similar process, because a student may connect reaction like this because he may find that Friedel-Crafts alkylation is like this and I go will like this, but actually what will happen? the reaction will be like this. Acid base reaction will prevail. Whenever there is a acid base reaction, it will prevail nucleophilic substitution reaction. Acid base reaction prevails over the nucleophilic substitution reaction. Okay, so this will happen, and when the lone pair will be donated, oxygen will get positive charge. That positive charge will be removed, and from the AlCl3, Cl minus will be removed. So this will form. Now, so first we need in the equimolar amount of phenol and AlCl3, then additional amount of AlCl3. This AlCl3 is what? Additional catalytic amount. Additional catalytic amount.
Yes, sir.
Along with what? RCl. Along with RCl will give what? Now the phenol is bonded with AlCl3. I think I have taken wrong color. The phenol is bonded with the AlCl2. Okay, this color is visual, na?
Yes, sir. Yes, sir.
Okay. So this AlCl3 is having vacant d orbital. Lone pair will be engaged with the Al, so availability of lone pair with the benzene ring will be less. Okay, and this lone pair, so this lone pair will not be donated to further any AlCl3. Now the AlCl3 will connect with what? Cl. R will be generated. That R will get nucleophilic attack from the benzene ring. Finally, R will get bonded. Getting my product, na?
Yes, sir.
So we'll get R here. O Al Cl2. This is ortho, and another will be what? Sorry, this is para, and another will be ortho also. Ortho will be minor, para will be what? Major.
Major.
Now, in the final step, what we'll do? We'll add some acid. We'll add some acid and we'll heat. When this will occur, what will happen? This O will become OH. Okay.
Yes, sir.
So when the acid, it will be heated with the acid, O become OH. So please note it. So if you find any step in your mind, you must express. It is not necessary that we think in the same way. What is the important? If we have a different approach for a reaction, we can discuss, and that will make your concept more clear.
Yes, sir. Yes.
Shall we go to next reaction, or you are making notes?
1 minute, sir.
Okay. Complete. No problem. Complete it.
Yes, sir. Yes, sir.
Okay. Then we have another reaction. For alkylation of phenol, what we do, the preferred method for the alkylation is taking the alcohol and this alcohol is treated with what? HF, and it gives alkyl substituted phenol. Huh? So what is the role of HF? It is a weak acid. Huh?
Yes.
Weak acid. So some of the molecules of alcohol will get protonated,
Yes.
and when it will get protonated, it will leave molecule in the form of H2O. Carbon
Yes.
will become positively charged, and at that carbon there will be electrophilic nucleophilic attack from the benzene ring. Okay.
Yes, sir.
So please note it.
Yes, sir.
Okay. Then we are coming to the Friedel-Crafts acylation reaction, similar to alkylation. In the acylation, what we take? Acid, chloride, or halide, anything you can say. For general name, you can say acid halide, and AlCl3. Again, like previous case, we need AlCl3 in the axis. Why axis? Because first all the phenol will react with the AlCl3. Huh? Then the
Yes, sir.
remaining AlCl3 will take Cl minus from this RCOCl, and
Yes.
that electrophile will get bonded. Huh? Now the second reagent what will do? Will take H3O plus and heat. Why we are taking H3O plus and heat?
Uh, to form alcohol, OH.
OH. Yes. The aluminum bonded with the oxygen will be removed when we heat it with the acidic condition. Huh? So finally we will
Yes.
get OH. Okay. Another reaction. The substitute. If we don't want to take excess of AlCl3, we don't want to perform reaction this in this way, we have another method. We take acid, carboxylic acid,
Yes, sir.
and with the carboxylic acid we take Lewis acid like BCl3, BF3, BF3. That
Yes.
BF3 will take OH from the carboxylic acid. CH3 C double
Yes.
bond O will be generated, which will act as electrophile, get bonded to the what? Phenol, and will get desired product, that is carbonyl at the benzene ring. So this BF3 is what? Lewis acid. Now what is the role? It takes out OH minus. It takes out OH minus from carboxylic.
Yes, sir.
Okay. Then we have another reaction. REI, reamer, Timon, TIE, MA double N. Reamer Timon reaction. Huh?
Yes.
The reaction, this reaction very important. Make it 4 star. Huh? Many times this reaction appears in the JEE exam. JEE means JEE advanced as well as JEE mains. Huh? In both
Yes.
the exam you will find this reaction appear many times. Huh? So reaction is what?
Yes.
We take phenol and it is reacted with chloroform in the NOH basic condition. Huh? So phenol is reacted with chloroform. This is chloroform. We call it chloroform with the NOH, and the product form is O minus basic condition. It will become O minus Na plus, huh?
Yes, sir.
CHO CHO. Along with that, the chlorine will be with the Na, so NaCl. There are 3 chlorine, 3 NaCl, and there will be 3 molecules of water. So if you will balance it, we will need 4 NaOH. Huh? When this compound is treated with H3O plus, what will happen? This compound will be treated with H3O plus.
OH.
This will
OH.
become OH, and this will be CHO.
Sir, why ortho position?
Yes, yes. Why ortho? We are coming to that point. Huh? First, let me explain briefly. I will explain the mechanism, huh? Because
Yes,
it is
sir.
important. Huh? Okay.
Yes, sir. Yes, sir.
So what happens? This CHCl3 reacts with OH minus and forms CCl3 minus along with H2O. So what is the reaction? This H is taken as H plus by the OH minus. Huh? So when the H plus will be removed, the negative charge will appear and it will become what? CCl6. If you relate it with the structure, what you will find in the CHCl3 there is a hydrogen, and 3 chlorines are bonded with the carbon. So the carbon, actually presence of these chlorine, what will be the action of these chlorine? These chlorines are electron withdrawing group. Huh? So due to this electron withdrawing nature of this chlorine, the electronegativity of carbon will increase, and under the basic condition, what will happen? OH minus will donate electron and this carbon will take away the bond pair. So becomes C minus Cl, Cl, Cl plus H2O. Look, now the carbon is negatively charged and it is bonded with the high electronegative atom. So what will happen? This Cl will take away the bond pair. Huh? And then what will happen? It becomes CCl2. What do you think? It will be positive charge or negatively charged? When this CCl2 will form
Neutral, sir.
neutral. How many electron will be present in the valence shell of CCl2? Whether the octet will be complete or incomplete?
Complete, sir.
Incomplete, yes. So how many electron will be there?
4.
Look, this is the bond pair of carbon hydrogen. Who has taken this
Yes.
bond pair? Carbon. That's why we are putting negative charge. In these two
Yes.
electron, one of the electron belongs to hydrogen and taken by the
Yes.
carbon. That's why we are putting negative charge. And whenever we show negative charge, it is understood that carbon is having extra electron. So there is a lone pair, and when the Cl leaves, it takes away the bond pair. So this lone pair remain what? At the carbon, yes or no?
Yes, sir. Yes, sir.
So this carbon will have what? 6 electron.
6
Incomplete
electron.
octet. Incomplete octet. It can act as what? Electrophile. Understood?
Yes, sir.
Okay. Now, with the NaOH, phenol become what? Phenoxide. With the NaOH, phenol will become what? Phenoxide. So
Yes.
this will be the next step, reactant for the next step. From the chloroform, we'll get this compound is called dichlorocarbon. I will write the name also. Have you heard about this?
No, sir.
Okay, no problem. Dichlorocarbon. It is very famous. You will find this again 3-4 times in the next chapter. Huh?
Yes.
Dichlorocarbon. So dichlorocarbon is obtained from chloroform, and this phenol releases H plus because the condition is basic and become what? Phenoxide. Huh? So this
Yes.
is our electrophile, and this is our nucleophile. Look, the nucleophile is again ambident. Yes or no? Ambident or not?
Yes, sir.
It can have nucleophilic attack from ortho or para
Pi
position,
bond. Yes, sir.
and it can have nucleophile from the oxygen also. What do you think? Nucleophile, electrophile is weak or sorry, soft or hard? What do you think? Electrophile is soft or hard? Do you see any positive charge on the carbon? What is the condition we have seen? For soft electrophile, low intensity of positive charge. Hard electrophile,
Yes, sir.
high intensity of positive
High
charge. Do you
intensity of
find
positive
any
charge.
positive charge on the carbon? No.
No,
So
sir.
basically it is a electrophile, and what kind of electrophile? Soft electrophile. Yes.
Doctor.
So from which nucleophilic side attack will be preferred? From oxygen or carbon? So this oxygen will
Carbon,
be
sir.
what? Hard. And carbon
Yes.
will be what?
Soft.
Soft.
Because less
So the question arises, there can be attack from ortho as well as what? From para. Question
Yes.
arises, there can be attack from ortho as well as from para. Why I have represented ortho as a product, why not para? That question remain unanswered. We are going to see that also. So
Yes.
let me first complete this step. What we are going to do, we will take nucleophilic attack from the benzene ring to the carbon. So what will happen? Any of, let me take it from this ortho side also. We can have attack from this ortho side also. This will form,
Yes, sir.
Now we can see there it will be resonance stabilized because this pi bond will come to this place, this pi bond will come to this place also.
Yes, sir.
Give the negative charge. So better we can draw the resonating structure also. So double bond O, CCl2, H pi. And look, carbon will have a negative charge. Carbon will have a negative charge because it is neutral and gaining a electron pair, so it will what? It will become negatively charged. Okay. So this
Yes,
will
sir.
be the. What do you think? Out of these two resonating structure, which one will be more stable? First one or second one?
First one, sir.
Why?
More negative charge and more electrons.
But you look at in the first structure, this carbon is what? Positively charged. And positively
Yes.
charged carbon have incomplete octet. Incomplete octet.
Yes, sir.
But in second structure, all atoms have complete octet. All atoms have
Yes.
complete octet. Okay. So let's come to the point. So now what will happen? This H will be released. This bond pair will come to the ring. There will be gain of what? Aromaticity, and we'll get O minus CCl2 minus.
Yes.
Okay. So what do you think? This O minus, why ortho? The answer is very unique in this case. That is very unique answer. Applies to, and in fact give me some time because that will become a very a little bit longer concept. That will need 10-15 minutes. In the next class, I will explain why this one, because still we need to form product. So this carbon, this negative carbon will take water H plus from the water and become O minus CH Cl2. Okay. Now
Yes.
condition is basic, so OH minus will attack, and the carbon from the chlorine from this place, when there will be nucleophilic attack from OH minus, the chlorine will leave. What will happen? O minus CH Cl OH. This will be again the lone pair from oxygen will be donated, second chlorine will also leave. And when the lone pair will be donated, oxygen will get positive charge, and that positive charge will be managed by releasing what? H plus to the what? OH minus. And as we know, reaction have basic conditions, so definitely there will be OH minus. So what will be the final? O minus, this carbon will get what? C double bond O, and what will be left? Hydrogen will be left, and this will be our final bond. Okay.
Yes. Yes, sir.
Okay. So we'll keep today's class up to this. In the next class, we'll have 5-6 reactions from phenol. Then we'll move to what?
Yes.
Aldehyde. In the aldehyde, we have to cover all the preparation reaction. After that, we need to cover some nucleophilic substitution reactions also. Okay. So
Okay.
2 class will be required definitely in the 2 class. And one more thing, Vishnu, if you have any doubt in any question, like if you have attempted a question, you may have some doubt.
Yes, yes.
So definitely
Yes.
share those doubts with me. I will discuss in the next class.
Yes, sir. Yes.
Okay. Thank you.
Thank you.
Can you
Thank you.
one more thing, Vishnu?
Yes, sir.
Uh,